right, guys, so check out this equation on the top. This is the exact same one that we had started talking about standard form before. And so we're going to introduce how to find the vertex using this equation. So remember, our A value was 2, B 12, C 13, and we already said that we got this for free. This is my y-intercept. So my x value is 0, my y value is 13, my y-intercept. Okay, so we know that for free. We get that right there, my c value. But we need the vertex, otherwise we can't graph this. Okay, we know the stretch, so we know we're going to multiply all of our normal y values by 2. But what's the vertex, right? So here's how to find the vertex. The x value of your vertex is negative b over 2a. That's why you need your a's and your b's. So negative b over 2a, whatever you get for that, will be the x value. Now the y value looks complicated as heck, but it's just f of negative b over 2a. Okay, and I know that looks like super scary, but really all it's saying is whatever value you get for x whenever you solve negative b over 2a, you're just going to plug it in and then solve for your y value. And I'll show you in a second, but that's all it means. You're just going to take the answer you got, plug it in, and then you're good to go. All right, first step, negative b over 2a. We're going to solve this right here, okay? Well, b is 12. Okay, so if b is 12, negative b is negative 12. Okay, it's the opposite. So instead of saying negative b, you can also say opposite b. So negative 12 over 2 times whatever a is. Well, a happens to be 2, right? So we just plugged in b and a, and now we're just going to solve this, okay? Here we go. Is this black or purple? I'm not even sure. All right. So we obviously have negative 12 on top, and 2 times 2 on the bottom is 4. And then we divide this, and negative 12 divided by 4 is negative 3. All right, so this is the x value of your vertex. It's negative 3. That literally goes right there. That's where this came from. So we're going to start writing out our vertex over here. I feel like that's purple. Let's make this black. Oh, blue, violet. My apologies. Let's get black in there. All right. So we're going to start writing out our vertex now. Vertex. And the x value is negative 3. We just figured that out by doing negative b over 2a. Now we plug in negative 3 into the equation and solve for y. So we're basically saying if we know that x is negative 3, what does y equal whenever x is negative 3? And that's where the vertex is going to be, right? So y equals 2 times, let's throw in our negative 3, 2 times negative 3 squared plus 12 times, and we're just going to put our negative 3 here, negative 3. See, everywhere there was an x, we just plug in a negative 3 because we already know x equals negative 3 at the point we care about, plus 13. So everything else is the same, but we just plugged in negative 3 for all the x's. Now we solve this, and guess what method we use? PEMDAS. So solve the exponents, parentheses first, nothing to solve inside there, solve the exponent. So the very first thing we have to do is say, what's negative 3 squared? Okay, negative 3 squared means negative 3 times negative 3, which is positive 9. And then 2 times positive 9 is 18. So this whole section right here equaled 18. Okay, the next one says 12 times negative 3. That's a negative 36, okay? And then plus 13, because that's all we have to do at the end. Now, y equals whatever the heck all that adds up to. Okay, so if you get out your calculator, or however you do it, and you put 18 minus 36 plus 13, you end up getting negative 5. So y equals negative 5 when x equals negative 3. So you just found the y value of your vertex. This was that. All we did. So all this right here and the answer went to that. Okay, so that's how to find the vertex. So now that we know where the vertex is and where the y-intercept is, we can definitely graph this, right? So let's think about, we have the stretch, the vertex, and the y-intercept. And so let's go to Desmos really quick and graph this. All right, so hopefully you can see Desmos. Let's go ahead and type in the equation. So we got 2x squared plus 12x plus 13. So here's our graph. And there's a few things that we want to know. Is our vertex correct? So hopefully you can see my mouse here. -3, -5. Boom. Look at that. We got it right. That really is where the vertex is. And so once you can place the vertex, you know the graph's facing up. Then you could just use the stretch if you were graphing this, and you'd say, okay, over 1 up 2, put a dot, right? And then you can do that on both sides, over 2 up 8, and that's going to be up here somewhere, right? Am I in the right spot? Be easier if I give you guys a table. There it is, over 2 up 8. So see, you can graph the rest of the parabola just by knowing where the vertex is, what the stretch is, and if it's going up or down. Everything else goes back to that table that I talked to you about. Now, let's just remind ourselves of vertex form. If you know the vertex and you know the stretch, you know vertex form. So we know the stretch is 2, and we know the vertex is x minus h plus k. Well, my h value is -3. So if I throw a -3 in here, okay, and then my y value or my k value is -5. The only problem is we have 2 negatives here, and that turns into a positive. So now my equation is 2 times x plus 3 squared minus 5. Now, there's the vertex form. We should be able to toss it in here. And what do you think's going to happen? If we did it right, the parabolas should fall on top of each other because they are the exact same parabola, right? The exact same parabola. One's in vertex form and one's in standard form. Okay? All right. All right, so with that being said, I'm going to finish this up by saying I still do want you to complete this task, but I want you to ignore all the words, okay? Let's not bring in the drama today. What I do want you to look at are the equations. If it gives you an equation, I want you to tell me what the vertex is. Okay, tell me what the vertex is. So that's number 1. So this equation right here, you need to tell me what the vertex is. Then the one below it, I want you to tell me what the vertex is, okay? Then it's going to go down. It has the same equation, and this actually gives you a nice area on number 3, and you need to graph it also, okay? And then put it in vertex form, okay? That's what number 3 is saying. Number 4, I just want you to go ahead and tell me what the vertex is, okay? Don't worry about it being a perfect square or anything. But what is the vertex of that parabola? And then put it in vertex form. So what's the vertex and what's the vertex form? Okay, then you're going to go ahead and go down, do number 5, same thing. What's the vertex? What's the vertex form? If it gives you a graph, you need to graph it. Okay, so you should be practicing your graphing. But so far, just give me the vertex form. And then 6 and 7 and 8, all the same thing. I want you to practice what I showed you, the -b over 2a, find the vertex, figure out what the vertex form is. And then actually for those 4, I would really love to see you graph it. Please don't graph it in Cami. Get yourself your comp book, make some axes. I want you to practice going over and up, especially with those stretches. That's a really good skill to have, okay? So make sure you look back in your notes if you forgot, or come to office hours and I can remind you, or message me right now in class so I can remind you how to use that table if you need, okay? But you do have that in your notes. I have gone over that a couple times. So I'm looking for graphs for 6A, B, and 7 and 8, but also what's the vertex and what's the vertex form for everything else. Other than that, you can pretty much skip what the problem is actually saying. All right, guys, have a great day.